Good morning, everybody. Last lecture we have learned about Dalton's atomic model and Rutherford's atomic model. Today we are going to learn perfectly black body and Planck's quantum theory and Bohrs theory. Perfectly black body, what is the meaning of perfectly black body? The body which absorbs energy or light completely or emits completely, such type of black body is called as perfectly black body. There is one black body which is known as Theory's black body, which absorbs about 98% radiation and also emits the 98% radiation. That is Theory's black body. You know, Theory's black body is double-walled hollow sphere. Double-walled hollow sphere having an aperture. This is the aperture. Inner surface is coated with lamp black. Outer surface is coated with nickel polish. It is having one projection. When light enters or energy enters from this aperture and falls on this projection, then it will absorb 98% of energy and it will reflect in different directions. When this body absorbs 98% radiation and after heating it will lose that energy or it emits that energy. Therefore this body is called as perfectly black body. Then we will see the Planck's quantum theory. Planck's quantum theory. In 1900, Planck studied the hot body radiations at different temperature, and he found that light radiation emits or absorbs not in a continuous manner but in discontinuous manner. That theory is known as Planck's quantum theory. Continuous means this type. This is continuous wave. Light absorbs or emits radiation not in continuous manner. This manner it is not present, but it emits or absorbs radiation. This is discontinuous manners. Light absorbs or emits radiation in a discontinuous manner, in small packets of energy. That packets are known as quantum or quanta or quantum. Single it is quantum, plural it is quantum. This theory is known as Planck's quantum theory. Means when light radiates, emits or absorbs energy in the small packets or bundles are also called as discrete units. Discrete means small. Light emits or absorbs in small packets of energy or in discrete units, that is called as quanta. And each quantum of radiation is given by some energy, that is E is equal to h nu, where E is energy, h is Planck's constant, and this nu is frequency of radiation. H is equal to 6.62 into 10 raised to minus 34 joule second. You know the mu is equal to C by lambda. Therefore, E is equal to Hc by lambda. Energy of quantum of radiation is directly proportional to frequency of radiation and inversely proportional to wavelength of lambda. Further, it is energy of radiation is quantized. Quantized means E is proportional to or equal to whole h nu, 1 h nu, 2 h nu or 3 h nu. It is having value like this. Such energy is called as quantized energy. Okay, these are the 3 to 4 points of Planck's quantum theory. One point is energy emits or absorbs in small packets or discrete units known as quanta. Energy of each quanta is given by E is equal to h nu, or it is equal to Hc by lambda. Therefore, energy is directly proportional to frequency of wave radiation and wavelength of radiation. Third one is energy is given by whole numbers. It is equal in numbers. It is not found in point h nu or 3 by 2 h nu. It is not found in such a way. It is found only in whole numbers. Therefore, it is called as quantized. Energy is quantized. Okay. Next point is Bohr's theory. Bohr's theory is based on Planck's quantum theory. Bohr's theory is based on Planck's quantum theory. We have seen that in Rutherford's theory, nucleus is present in the center and electrons are moving around the nucleus. Positively charged nucleus is present at center and electrons are revolving around the nucleus. We have seen in Rutherford's theory, but this theory fails to explain stability of electron. Why? When it is moving, it gets accelerated. Electrons are moving around the nucleus, it gets accelerated. Therefore, it loses energy and it falls into nucleus. Therefore, it is not stable. Atom will not be stable, but atom is stable. Therefore, this theory fails to give the stability of electron. Bohr's theory explains these drawbacks. First assumption of Bohr's theory is that positively charged nucleus is present at the center and electrons are revolving around the nucleus in a particular orbit with constant energy. Similar energy, there is no change in the energy, revolving with constant energy. That is first assumption. Electrons, positively charged nucleus present at center, positively charged nucleus is present at center and negatively charged electrons are revolving around nucleus in a particular orbit with constant energy. In Rutherford, it is accelerating and loses energy. Therefore, there is different energy, not constant energy. Here is main point of this Bohrs theory is electrons are revolving in a particular orbit. Circular path is called as orbit with constant energy. This is first point. Second point is angular momentum of this circular path is given by mvr is equal to nh upon 2 pi, where r is radius of electron, h is Planck's constant, n is orbit, where orbit number is given by 1, 2, 3, 4. These are known as energy shells. Okay. In this theory, electron is having constant energy, but electron can jump from one orbit to another orbit. Electron can jump from one orbit to another orbit, that is given by delta E is equal to H, change in energy. Bohrs theory, and then merits and demerits of Bohrs theory. Merits and demerits. Merits, what merits? What are the merits? It tells this theory is applicable only for single electron, which is having one electron, atom or element which is having single electron. This theory is applicable only for having single electron in an atom. For example, proton is, hydrogen is having single electron, and lithium plus is having single electron. Such type of atom or element is applicable for this theory. Demerits. What are the demerits? This theory is not applicable for having electrons more than one. The second point is this theory does not explain the fine structure of hydrogen atom. Fine structure of fine spectrum of hydrogen atom. Fine spectrum of hydrogen atom. Fine spectrum means, suppose this is line, one line, which is shown by this Bohrs theory. But after high resolution power used, then this line will be split into small lines, fine lines. These lines are called as fine spectrum. this theory does not explain this fine spectrum of hydrogen atom, and this theory does not explain the uncertainty principle. Third point is, this theory does not explain the uncertainty principle. And fourth point is, this theory also does not explain the dual nature of atom or particle. Okay, in the next period we will go to our main syllabus, photoelectric effect. Okay.